Now we will be talking about the concept of resistance. Resistance means obstruction. Obstruction. Tell me, is it good? Many of you will nodding your heads negatively that no, it's not good. But think about a school scenario that there is no teachers. All the kids are running, playing, and there is nothing but the chaos, unnecessary noise and all. There is no discipline, nothing, right? But when there are the teachers, when there is a presence of the team of teachers, all the students will be standing in a proper manner with proper conduct and discipline, right? So to run a school environment properly, teachers are the must, right? In current electricity, resistance is like that. It controls the flow of current. Yes, it is obstruction, but without this obstruction, flow of current will not be going in a proper manner. Okay, so write it down in your copy that resistance can be defined as the obstruction offered to the flow of current by the conductor. Okay, now write it down in your copy. Another very important question that can be asked in your exam, that what is the cause of resistance, or discuss about the causes of resistance. I'm dictating you the answer. Write it down in your copy. The resistance of a conductor arises due to the obstruction offered to the flow of electrons by the atoms or ions of the material. When an electric current passes through a metallic conductor, put a comma and then write, the free electrons move through it and frequently collide with the vibrating atoms. Put the full stop. Then write, these collisions oppose the motion of electrons, thereby causing resistance. The amount of resistance depends on the factors such as the length and thickness of the wire, the nature of the material, the temperature, etc. Thus, the resistance is essentially the opposition offered by a conductor to the flow of electric current due to electron-atom collisions within it. Next, we are moving to the Ohm's law, the most important part of this chapter. Ohm's law. What is the statement? I'm just reading the statement from your book. No need to write it. So according to Ohm's law, the current flowing in a conductor is directly proportional to the potential difference applied across its ends, provided that the physical conditions and the temperature of conductor remain constant. So symbolical representation of Ohm's law is V equal to IR, where V is the potential difference, I is the current, and R is the resistance. Now, if I break this particular law, then I will be getting some relations. What are the relations? V is proportional to I, directly proportional to I. V is directly proportional to R, right? Now, from V equal to IR, I can write that I equal to V by R. So from this I can also write that I is directly proportional to V and I is indirectly proportional to R, right? So it's very obvious, no, that the flow will be disrupted, there is more obstruction, and the flow will be easy flowing when the obstruction is less, right? And again, R equal to V by I. So the same thing, R is proportional to V, R is indirectly proportional to I. So why am I writing all these things, all these same things again and again? Because the numericals will be coming from this particular part. How? Let me show. For a metallic conductor, say A is a metallic conductor, B is another metallic conductor. In case of A, in case of B, current is denoted as I1, resistance R1 and potential V1. In case of B, I2, R2, V2. Okay. Now, if I am coming to this particular relation, these two relations, V proportional to I and V proportional to R. So, V is equal to some constant into I. When we convert the proportionality sign into the equal sign, we have to put a constant. So, V by I is equal to constant. So, in case of A, it is V1 by I1 is equal to constant. In case of B, V2 by I2 is equal to constant. So, can we equate these two terms? In your mathematics, you already know that if A equal to B and B equal to C, then A equal to C. Similarly, V1 by I1 is equal to V2 by I2. This is very important relation which will be helpful while solving a numerical problem. Another, taking a indirectly proportional relation, and I am taking this one. R is proportional to 1 by I. R is proportional to 1 by I. 1 by I. So R is equal to some constant by I. So IR is equal to constant. In case of wire A, it is I1 R1 is equal to constant. In case of metallic conductor B, it is I2 R2 is constant. And now constant. Okay. Now I'm just equating this to I1 R1 is equal to I2 R2. So see, I1 by I2 is equal to, here it is R2 by R1. This is another formula. So I'm giving you a list. Write it down in your copy and trust me, it's very helpful for your exam. Now you can take a screenshot, and if you have any doubt, let me know. Now there are two types of resistance. One is ohmic resistance, another is non-ohmic resistance. Ohmic resistance are those which follows the Ohm's law, and non-ohmic resistance means it does not follow Ohm's law. Okay, so ohmic resistance follows V equal to IR. It does not follow. Okay, now there is a difference when we will be drawing the IV graph for the ohmic resistance or the ohmic conductor, non-ohmic conductor. So middle conductor and the other. So put the subheading that IV graph. IV graph for a metallic conductor. Here I am placing I in the vertical axis, V in the horizontal axis, and we know that V equal to IR is a linear equation. So it will be a line. So it is the graphical representation of Ohm's law. And now if the non-ohmic resistance wala case occurs, it is a non-linear resistance in case of non-ohmic resistance by conductors, the graph will be slightly different from this. Use your scale and pencil while drawing this up, and it is a non-linear curve. This is for non-ohmic conductors.